If you find these videos helpful, please consider supporting AddOhms and the Bald Engineer on Patreon. Hello, my name is James and I'm the Bald Engineer. Let me make sure my mic is on. Looks like it. Welcome to an AddOhms live stream. This is going to be a working live stream. I actually have a project coming up where I need a couple of circuits, and instead of kind of doing them off in the dark, I'm going to do them live, which is interesting because for the longest time, I have wanted to do a live stream during the day, during the week. Usually I do them on the weekends or at night, but I took this week off since it's a holiday in the US. And so I figured why not at least one day this week I wanted to do a live stream. I hope you guys enjoyed the trivia. I put that together earlier this week. For a while, I wanted to have something happen during the intro that was more interesting than just watching video. And so eventually, I'm going to have a bot that will keep track of your answers and score points and things like that. I just haven't gotten that far. But I have been able to at least get it to the point where everything you see is dynamically generated. And so as I add more questions and I add more features, you'll see that change. I just wanted to point that out because it's not a video. It's actually some JavaScript on what you see, and in the back end is some Python. With that said, I did want to talk a little bit or real quick about the Arduino question. So the trivia question was, what's the maximum output of an Arduino Uno's I/O pin? And so where that comes from is the absolute max in the data sheet for the ATmega 328P is 40 milliamps. And what that means is anytime you look at an active components data sheet, the absolute max section is the conditions at which you start to cause damage. And so ideally, you want to operate below whatever that threshold is. And so in this case, the data sheet's absolute max is 40 milliamps, but the recommended value is between 20 and 35 milliamps. And so I noticed a couple of you said 20, a couple said 35. Those are both numbers that get thrown around in tutorials and on the internet. But the absolute max you should ever draw out of an I/O pin on an Uno, which is based on the 328P, is 40 milliamps. All right. I want to say hi to everybody in the chat. Appreciate you guys playing the trivia and saying some things. I'm just going to say hi, everyone. Yeah, actually, I tell you what. Let's just go right to that datasheet thing because I want to. There's actually. Okay. Sorry. Let me back up. Here's what we're going to do. I've got this circuit, and my plan. Oh, that's not going to work. I might need to grab a mouse for this. I don't know how to unzoom it. Well, that's not useful. All right. Hold on. Just get this taken care of right now. How many ways can you insert USB? The first way, the second way, and then the first way again. All right. I don't like this mouse because it clicks so loud. Okay. Why don't we just do this? I'll move this over here. This can basically go right here. That'll be fine. Let's go ahead and put this. I know what's going on. This should be over here. And then I can minimize this because I can see it in front of me right now. All right, that's better. Okay, so this is what we're going to be doing in a little bit. I want to build this circuit, and I've got a couple others. We'll see how time goes, which will actually be connecting it to an Arduino later. But I wanted to bring up, let's see, I should have the data sheet. I wanted to bring up the data sheet so we can examine what the data sheet says together. I'll bring this over here. So we're going to go down to electrical characteristics. And this is, how do I kill the tools. Oh, I know what I can do. I'll just do that. So if we look, there is a section here. How do I zoom in? Man. So this is for the ATmega 328P, which is the chip that's used in the Uno, the Nano, all of the 8-bit non-USB native Arduinos. And you can see that the absolute maximum rating, the DC current per pin is 40 milliamps, and the total current for VCC and ground is 200 milliamps. And so that's another thing to keep in mind, is that you can only have like 5 or 6 pins syncing or sourcing the total amount of current, like 200 milliamps of current. So that's another good reason to think about why you should use a lower value. But what this value means is anything above 40 milliamps is going to cause damage to the component. And so you run below that. And that's where that 20 or 35 milliamps comes from. Now, since we're on this topic, I just want to point out another place where this bites people. Make sure this is still okay. So here is the datasheet for the FQP30N60L, which is or N06L, which is the logic level MOSFET that is very popular. The reason I want to point this one out, hold on a second. The reason I want to point this one out is because a lot of people will ask me, well, okay, what is VGS for this transistor? If I look at it, it says here that VGS is plus or minus 20 volts. And again, this is the absolute maximum rating. And so what this is telling us is if you apply more than, where'd it go? If you apply more than 20 volts to between gate and source, you can potentially damage the transistor. That is not the threshold voltage. Just like all components, the absolute max is the maximum ratings. You want to go and look at the characteristics chart to find out things like the threshold or the ideal operating conditions. Now, in the case of a microprocessor like the 328P, there isn't a recommended current. It is just the max. And so that's why tutorials for Arduino tend to say 20 or 35, because they're just trying to say, hey, here's a safe limit to use. Okay. Yeah, sorry about the double chat. There's just a few things that I can't do. I'm trying to set things up for a specific purpose today. So, okay, anyway, I wanted to cover that trivia question. I might run the trivia again when we're at the end, just for fun, so stick around. And anyway, let's get to building a circuit. And so here we go. I've got this guy, and I'm going to be open to guesses to what I'm building. But and if somebody guesses right, I will acknowledge it, but I'm going to keep it a mystery until I get it farther down the road. So let's do this. From the chat, going with the max, living on the edge. All right, so I think I did this all with PNP transistors. So let's get some 3906s out. I need 1, 2, 3, 4. When I change, is there something going on with the audio? Yeah, well, I can't fix that now. All right. All right, so we need 1, 2, 3, 4. Check this guy out. This is a cool device I did a review on Element 14 for. Basically, what we can do, I need a couple of pins. Which I'm going to use wires for. So I sometimes struggle reading the parts that I have, as well as I have this whole box of old or cheap transistors that I don't trust. And so I've got this little transistor tester that tells me a couple of things without any effort. So what we're going to do is we're just going to hook this up, make a little test jig, because I want to make sure that all 4 of these transistors are 3906s and that their pinouts match so that we don't make any mistakes. All right, PNP, and it's telling me that it goes collector, base, and emitter. So let's write that down. Oh, sorry guys, I'm just looking for a pad of paper. All right, so get this back. Is it a breadboard with golden rails? No. 4-pin voltage controlled DAC? No, but that would be fun to build. So this is going, let's just go flat side. Blue is emitter, green is base, and red is collector. All right. Make sure these are all the same. Because I can actually look at them. Yeah. Well, actually, I can look at them. The reason I'm doing this is I have had bad transistors in this pack, and this tester is just good enough that it can usually tell if one of the junctions is shorted. So we just want to make sure that that's not the case. 2, 3, 4. 5 plus 1 extra. Perfect. All right. Put that aside. This is going to be for my reference later. Put these off camera. Now we need some resistors, which is what I was looking for earlier and don't remember where I put them. Can I borrow some resistors from somebody? Just teleport them over? That would be fantastic. Switches, retro project capacitors, USB, caps, sensors, PCBs, SMT, sticky in audio, USB resistors. Totally in the wrong place. Okay, so we'll need some 1Ks or something roughly 1K. That's just for current limiting. 200 ohms is a little bit small, but that'll be convenient. And then this is going to be tough. I don't know that I have exactly what I showed. So here's a 100K. These used to be in order. Looks like a 47. Nope. That's a 470. 50, 200. Did I do a 1 meg on this design? Nope, that's the other circuit. 200. 10K. I know these are like huge. So what do I need? I need a 1K, which, okay, there's my 100. Okay, 1K is going to be my problem. I don't have a package of 1Ks. I'm pretty sure that's like the one resistor I'm always out of. Yeah, shoot. All Okay, what's this? 2.7. Okay, backup plan will be, let's put two 2Ks in parallel. That should get me close enough for today's experiment. But I don't have a 2K. Really? There they are. All right. Let's see. My other thought is in this, oh, I don't need those. In this pile of junk, I probably have $1K resistors because they're the most popular ones I use, which is why I'm out of them. So we'll just look for something that looks like that has some red and black on it. And that will likely be what I need. Maybe like this guy. And oh, I hope I don't put resistors in there. That would be a terrible idea. Absolutely terrible. That's like 10K. This circuit only needs one. Okay. Well, that's going to be fun. Let's just double check. What? Oh, that's brown. That's not red. Darn it. Darn it, darn it, darn it. Well, that's why I double check. Ooh. Nope. That's like 30, what's blue? 5 or 6? Must be 6. How do I have no 1K resistors? This doesn't seem right. Okay. All right, whatever. Dumb resistors. My resistor bucket is a nightmare. Yeah, mine too. I keep saying I'm going to reorganize it, and then it stays organized for about one project. Okay, so let me just hold that off to the side for a second. So we need a bunch of 1Ks. Oh, wait a minute. Oh, I know what I was thinking. Well, this might work. These are just current limiting, so I don't really need 1K for that. This is the only one where 1K worries me. Steal some 1Ks from your other boards. Hold on, Martin's got a good idea. Let me check something. No, that's 470. Although, okay. Oh. You know what we can do? Okay. Yeah, that's what we're going to end up doing. Good idea, Martin. Because I've got plenty of 470 ohm resistors, so we'll just use that for the current limiter. And let's see, I can't read the bands on this one. This looks like, I don't like those. So let's go ahead and just, the leads on these are too thin. I think what I want to do is, let's just use two 470s, and that will be close enough for today. So we'll need 1, 2, 3, 4, 2, 4, 6. We'll pull out 8. Yeah, the only reason I was trying not to do the 2 in series is because there's the value of these resistors is going to be a little bit critical, and compounding error isn't something I want it to do, but we don't really have a choice, so that's what we're going to do. So we'll just do one of these. And then I'm gonna uh, 2K in parallel for more wattage. Let's think about that for a second. So yeah, because you get the same voltage, but half the current goes through it, so your effective power handling is doubled. But I'm not worried about the power handling capability. I just want the total resistance. The only reason I'm not going to do the 2Ks in parallel is because the leads I have on my 2Ks are really thin, so they're just difficult to work with. So instead, we'll just do these 2 470s in series, which ought to be close enough. So we'll go like that. And we will do this real quick. And so we're getting 926. Yeah, 926 ohms. So I need to keep track of that. I don't like this pen. So let's go, let's say R1K is equal to 926. It's going to be R100 is equal to R10K and R100K. Okay, so now we can find a 10K. Looks like that. Just make sure I'm in the right ballpark. You guys can't see that. That's better. So 994. Wait, what? Okay, 9.94. So 9.94K ohms. Let's just trim that up a little bit. Soldering those twists helps, I hope. Yeah, soldering them would be a good idea. I just don't want to pull out the soldering iron at the moment. And in the final design, I'll have a 1K resistor that I'll use, so we won't need to go that far for the moment. And the other reason I did the twisty thing is I could have just done like put them in series on the breadboard. I just don't want to take up more space than I need to. So, all right, so we got our 10K. Last time I did it on breadboard, it became intermittent. Yeah, actually, I actually try to throw my breadboards away after a while. This one's only been used one other time, and so I'm pretty confident it's going to make good connection. And the overall circuit is simple enough that a couple of ohm meter measurements will check our sanity when or if things don't look like they're working correctly. Let's see what this guy looks like. Looks like brown, black, yellow. I think that's exactly what I want. So let's get a little bit here. Oh, the twist got intermittent? Okay. Yeah. I'm totally with you. I'm not super excited about doing it that way, but like I said, I don't want to pull the soldering iron out just for that. What I would like to know is why I don't have more 1K resistors, but that's a topic for another time, I guess. 99.5 K ohm. All right. Do I have these in order? Got this one. So we've got this one, this one, this one. Oh, this is going to work out. All right, and then we'll need more of those in a minute. Put these away. When you cut off, remember not to drink from the bottom of your coffee cup. That is a pro tip. Was that from Robert? Yes, Robert. That is a pro tip right there. That is a really dumb place to keep my tea. Let's just move that right now. Compressor plus boost in one variable target window. Wow. What do you mean by compressor? Like audio compressor? Trust me, you only have to have it happen once. Yeah, I don't know that I've drank. Well, I'll put it this way. I don't know that I've never noticed that I drank a lead before, but it wouldn't surprise me if I did. Where are we? Oh, whoa. Yeah, that should be 100. Why is that measuring way off? Drop. Okay. 108 is a little bit higher than I'd like it to be. Let's try this one. I did just think of something. Yeah, okay. What is this one? That's also 108. Let's try these blue. Way at the bottom. How am I going to... I really don't want to do this. I want this one. That one, right there. That's what I want. $130? What? Oh. 1, 2, 3, 4, 5. Okay. Shoot. Okay, fine. We'll go with 108. I wanted something tighter, but we'll live with it. Better late changing T placement rather than be sorry. Hey Kaz, how you doing, man? Congrats on the new job. I know I said that in Discord, but I'll say it live as well. Okay. So what was this one? Its actual value? Now it's 109. Okay. You know, with it only being 100 ohms, I wonder if I do this. I was holding those wrong. Is it going to drop down? Come on. Oh yeah, all right, 108.9. It has more decimal points, so it must be more accurate. Okay. That should work well enough for what we need to do. Okay, so we've got my 4 resistors. Now let's go back to, we got 4 resistors. I've got a pile of transistors which are off screen. And so the way these are going to work is the collector goes to a resistor, and then that goes to, this is my DUT. So, but it looks like all of the resistors connect to one common side. Okay. And then each, okay. And then all of the transistors get connected to 5 volts or whatever VCC is going to be. And then, by the way, this whole section over here, or this little like switch that I've got going on, this is actually meant to simulate a GPIO pin, so I can either go high or 5 volts or ground. So we're not actually going to add push buttons. This is going to go to an Arduino. So I'm just trying to think through on the breadboard is how do I want to connect these, because they're the one half the resistors all get the same point. So we could do something silly like try to line up one of their legs all in the same column. But then I got to get all of these. No, we'll just use jumper wires. It'll make it easier to test that way. So why don't we do this? Let's put these all, well, I know a better way to do this. Let's build up one of these and then see if we can duplicate it. That's probably the best way to go about this circuit. So I'm pretty sure I'm going to want to have my resistor go this way. So we're going to do that. I don't like that at all. I have an idea what this may be now, but we'll wait and see. Yeah, actually, I did realize right before the stream started, the file names for the circuits have the project in them. the name of the project's in the file name, so I have to be careful. I mean, it's cool if you, I mean, I don't mind like you guys knowing what it is. I just thought it'd be more fun to have a little bit of mystery. And I mean, this isn't, I mean, you can see the circuit. It's really simple, right? So I'm not trying to fool anyone. I just thought it'd be fun to guess what's going on. So our emitter, where's this going to connect? It connects to the collector. This is probably what I want to do. And then we'll just jumper that to 5 volts, right? Right. I think that's all we're going to do. It's really pretty simple on purpose, actually. I will say, once I reveal what I'm building this for, this is by far not the best way to build this particular application. The reason I'm building it this way is for more of an educational reason. There's much better ways to do what I'm doing. It's more a matter of, so what we got, emitter, base collector, emitter goes, is just more of, it's more of a instructional thing. So I just want to point that out is this is not, if you were to build this actual application for reals, I would do it completely different. All right, so 5 volts to the emitter. And then let's go ahead and do this because we'll be building down here for a little bit. And then base is going to get a pin to the Arduino, which I'll do with a jumper wire. And then this goes to this common point, and then we will need to jumper all those together, which I'll do when I'm done. Okay, so let's use the transistor as our spacer. And then let's go 1, 2 holes over. And we will need another 5 volts. Yeah, that's why I'm not guessing. Yeah, I guess I should actually point out there's actually 2 things to kind of guess at. And once you figure out one, you may be able to get the other. So it's like I'm building this particular circuit. Okay, once you figure out what this circuit is, then it's like, okay, why am I building it would be the next. sort of level. All right, so that's in place. And then we'll move our super efficient and totally not going to mess us up 470K resistor doodad over to here and then here. Uh-oh. Yep. Okay. Now I'm going to do a resistance check just because I want to make sure that the breadboard is getting contact. So let's throw a wire into this column. Just come on, just get in there. And then let's go from here to here. Yep, cool. Okay, so that's in place. Oh, no, I'm putting those in there. All right, next transistor. 1, 2, over to here. Moldavia, switch current supply. No, that's not it. However, if you twisted some words around, that's a little bit closer to what I'm trying to build. Crude, but a little bit closer. All right, and then this collector connection will go here. Oh, this is cool. I think well laid out breadboard circuits are oddly satisfying. Or you might even argue they're just flat out satisfying. All right. Poop. I don't like that. And now my row columns are messed up. That's okay. The OCD will just have to pass on that one. All right. So let's look at this. So the pinout flat side was emitter-based collector. Emitter goes to 5 volts, 5 volts, 5 volts, 5 volts. Collector, collector, collector. And then we're going to use jumper wires on the base. Although, I guess what I could do, oh, I know what I'm missing on that base. All about the base, all about the base. How do I want to do my, let's check something. So we need our current limiting resistors. Geek, you said AN is specified wrong. I think I know what you're talking about. And to verify, why don't you go ahead and tell me what you think that number should be, and then I'll know whether or not we're on the same page. Because yeah, I expect it at 1 mega ohm. And if you think it's a different number, then we can then I can discuss why I did that. Because the 1 mega ohm is on purpose. It's appropriate for the sim, yes, but well, okay. I'll go ahead and just say what's going to happen. So, like I said a second ago, or a minute ago, over here, this is an I/O pin. So I'm just simulating putting out a high or low, and then over here I'm simulating a analog input. So an analog input into the Arduino, and so that's what's going on with this circuit over here. This is going to be my device under test, or DUT, and then this resistor was just meant to represent the input impedance of the analog input, so that I could see a certain number show up there. I'll leave that up for just a second while I finish this last current limiting. I'll throw this into here. Throw that there. Oh, I missed one. We need one more resistor. Wait. That's weird. Yeah, I'm checking my memory, but if I recall, the analog input impedance is between 20 and 200K. Okay, so I walked you right into a trap. Just like the current limiting of the I/O pin, there is a little bit of misinformation on the internet about the 328P's input impedance. Its DC impedance is 1 mega ohm. Its AC impedance is on the order of 10 or 20K, or 10 or 100K. And it's because it's a successive approximation, or SAR, analog to digital converter, which means there's a sampling capacitor which samples the voltage and holds it while the rest of the A to D figures out what is the voltage. And so if you read the input slow enough, the input impedance is closer to 1 mega ohm than it is 100K or 10K or whatever. And so the input impedance of the analog input, the thing that most people miss is that the input impedance is based on DC or AC. So the DC impedance is 1 mega ohm. It's once you start sampling and start using that input capacitor, that's where the input impedance drops. So, wow, bunch of follows. Thank you for everybody following. We are building circuits, which should be lots of fun, eh? Ah, it's a raid. Who came in? Who brought it in? T sodding. Ah, thank you, sir. Very cool. I need to get that. What do you call it? Alert set up, because I did not see that. So anyway, hey everybody, my name is James. You might know me around the internet as the Bald Engineer. I have a YouTube channel called AddOhms, and then you'll find me on a couple other places like Element 14 and Hackster. In this live stream, I'm building this circuit, which is going to be used in a future project. And so far, I've kept it a little bit of a mystery about what I'm doing. But if you want to make a guess, and if somebody gets it right, I will let you know that it is right. And T Sodding, thank you so much for the raid. It's good to see you. I enjoy your streams, so it's great to see your name show up in my feed. All right, is it a killer robot? Oh. Well, stream's over. Somebody figured it out. No, I'm just kidding. I do watch your streams. Yes. Yeah, actually, I'll have to double check. You might actually be on my auto host, and if not, you will be soon enough. Anyway, okay. So we've got transistors, current limiting. We've got the reason for doing the circuit resistors, and now we need to connect our bottoms. Boy, that sounds really bad. I wish I hadn't said that out loud. So I'm connecting, what am I connecting? The resistor, okay, now I remember. The resistors on the emitters all get connected together. So I make this bigger since it's spending most of its time down there. Connect our bottoms, preserve forever on the internet. Yeah, good point. Let's tag that and just get ahead of that one as soon as I can. shoot, missed the hole. Oh, good times. Good times, great oldies. Kill this. Pull this one, go to here. Man, I am just butchering these jumper wires. Let's try. You go in first, twist this one. Well, definitely gonna have to double check that these are making connection. They're having trouble going in. You know, why is it, I mean, breadboards are a standard size. So, and I have like three different wire kits. Why don't any of them always, why are there, I can't even think. Why are the links always wrong? Why can't, I don't know, never mind. All right, this goes to here, this goes to here, this to here. Okay, let's just do a quick sanity check. Okay. Ooh. Okay. What editor is this? It's a VI board, because VI is clearly the better editor. Actually, I don't have an opinion on Emacs versus VI. I started using VI first and I never switched over. Okay, so there we go. 1, 2, 3, 4, those are all in place. Now we need an Arduino, which I did not think to pull out ahead of time. Let's get Omega, Vidor, Yun, Maker 1000 is the one I want, and it's empty. Great. Also, it doesn't have all right, that Leonardo needs a new IC. This 0, we might do the 0. Oh no, well shoot. Okay, the problem is I want it to use the Maker, but I didn't solder any pins onto it yet. The 0 is the same processor. So for now, let's just use the 0. And go with that one. So jumper wire kits have lengths in 0.1 based on the resistor color codes. Need to jump 0.4 using yellow jumper. Really? Am I this many years old and I didn't know that? Huh. I'm really embarrassed that I did not know that jumper wires were color-coded. Well then. Well, Michael, thank you very much for learning me something, because that was not something I knew. Like, legit, I don't think anyone ever told me that. All right, cool. I'll have to keep that in mind. Okay, so here's what we're going to do. My final project is going to use the Maker, it's actually going to use the Maker 1010, but the 1000 is close enough, and that's what I have. However, for the purpose of prototyping this circuit, the 0 should work just fine. So let's grab a USB cable for it. Let's try this one. Let's go to USB. Let's make sure that there's nothing on this before we start using it. And I want to make sure that this cable is actually a data cable. Yeah, looks like it. Okay. Let's fire up Sublime. The question is, does this version of Sublime have, I need 32-bit M0, let's go 184. Let's get that installed. And then we're going to start a new sketch. We're going to call this live stream. Oh, just tell me it was complete. Okay. Open sketch, new sketch. Let's do live stream 3906s. Okay. Pin mode 13, output. While 1. Digital write 13 high. Delay 250, digital write. Yeah, just copy paste. Low. Tab. Save. Okay, so board is going to be it did not list it. Do I need to refresh this after doing the install? It's not listing the type. Interesting. Is it some type of memory storage circuit? No, it is not. Good guess, but no. Okay. Oh, that's why. Select the platform. And then we can select the board. And this is 0 programming port. And then do I still have to tell it the port? I don't know if it's 10 or 12. Why would there be two? All right, let's just upload, see if that works. That's what I thought. That never seems to work. So let's do platform. Hold on. I said platform. I did this one, which fine. I don't think I've used a 32-bit board with Sublime yet, and I don't know how to get the thing set up. I don't want to get caught up in that, so we'll just we'll do it the old-fashioned way. Refresh that list on the top boards list. I did that. Is there something under build options? Let's try full build. Let's see if that does something different. Yeah. All right. We'll take one quick internet look. Yeah, see that? My output, I'm not getting any of that. Okay. That is a lot more stuff than I want to do. So we're just not going to use it. All right, so copy. What I'll probably do after I verify the board works, I'm going to switch over and just do a, we'll just do like a, what do you call it? External editor. Because I really prefer to edit in Sublime Text. SAMD, that's Adafruit. Where? Oh, don't tell me it's not installed on this one either. I wonder if that's why it's failing. But I thought Steno used its own. Thought it used its own. Is there an advantage to using while one in setup over putting it in loop? No, I just wasn't thinking. So I do have the SAMDs installed. So what? So where is that? Oh, it was on the top of the list. Oh, I know what happened. Okay. All right. Why is it saying install this package? Shouldn't it already be installed? Okay, let's do an update. I don't know why that's there. Good catch on pin mode. I will definitely fix that. I think the 0 has a pin or an LED on 13. I didn't even think about that because I know that some of the 32-bit boards changed it. Okay, while that's happening, let me grab a couple of other wires. So we're going to need, do I already have these out? We'll need one like that, and I have no more. Okay, that will work. Well, this is not instilling me with a lot of confidence. Oh. Okay, Windows, you win. So this is going to be the base. I don't want to hook these up yet because I want to make sure that I program a dummy program before we do anything. And so we'll move those to I/O pins here in just a second. And then we're going to grab from here to ground. Connect that now. It goes slow because it's Windows. Yeah, you know, no comment. All right, installation completed. Now we can, let's see, so we're still on, so let's go to port COM10. So COM12 went away. Wonder why that happened. Let's try and do a upload now. Sure, save whatever you want it as. So I have compiler warnings all, show verbose, okay. What? Now it's complaining about the package. Really? Really? Why are you upset about... What am I missing? You know, this isn't supposed to be the hard part. Yeah, okay, MacGyver. I would actually much rather be running either Linux or Mac OS, but there's one program on my other computer that forced me into Windows, so I don't know what this means. I've never had this error before. Let's try, I'm just going to change the board type and see if it'll compile successfully. I mean, it's not even giving me any error messages, so I don't even know. Okay, I updated the package, right? So let's close and relaunch and see if that does something. Because that I don't understand why it's complaining. I've never had that problem. Is your port wrong? Well, the thing is though, I'm just saying to do verify, and it's failing to compile. So, however, the 32 bits do have the programming and the debug port. I mean, I'm going to try changing the board because it's under board type, right? Yeah. Let me try native and see what that does. Yeah. Board Arduino native is unknown. Okay, that's really a new one for me. I don't know what... Okay, you say it's solved. Let's see if that's the case. Yeah, it said something about programming port. It's because the programming port and the native port are two different board entries on the board list, and I had programming selected first and then native. but the error message is happening when I hit verify. And so something is wrong with the tool chain, which may explain why Sublime Text couldn't use it, because maybe there's a problem with the tool chain. You know what? No, because I really want to, let me think. Hold on a second. I want to stick to a 32-bit board because that's closer to my final application. So what if we just use a better or an alternative 32-bit board? Which one is this? That might work. Okay. I've got plan D in mind. I just don't want to go that far. Tools, boards, let's see. Wait. I don't think I have the Windows version or the store version. Pretty sure I have the download version. Okay, let's verify something else. Let me see if a feather will compile. Okay, so here's what we're going to do. If this works, which this is compiling, so the Adafruit toolchain works correctly. So what if we use, because all I care about is the M0 at the moment. And so one option could be, nothing on that one, is that we just do a 0, but then I've got to solder headers on, which isn't terrible. I just didn't want to do it. Data logger. Looks like a teensy. That's not what. That's going too far. It's the wrong processor type. That's a 32U4. That's not going to do us any good. Feather tiny. Nope, wrong processor type. Where's this logger one that I just had? That'll work. That'll work just fine. We're just going to have to put some headers on it. Really? Okay. So Kaz is thinking I've got the Windows Store version, which I didn't think I had. So let's do two things. Let's do, where's, Okay. Windows installer. Download. Why does the Microsoft Store have the Photoshop icon? And then let's do a search here. I know you can't see this entirely. I just wanted to look and see. Yeah, so I don't have the Windows Store version installed, but what I'm going to do anyway is let's just install and uninstall this anyway, because something is wrong. Yeah, the version is old, but I was going to say I've used it before for this board, but I guess I haven't. Because if I think about it, I don't even know when the last time I used this board was. So let's just go ahead and do it the right way. It's currently open. Oops. Not what I wanted to be spending my time on, but hey, if it's what we got to do, it's what we got to do. And then while that's happening, we're going to go and just make my backup plan happen. So we're going to go ahead and get some soldering going, because I don't trust that this is going to solve my problem. I'm plugging in my soldering iron, which you really can't see. Or one of my soldering irons, I should say. And we'll get this one ready to go. Okay. Uninstall. Yeah, thanks, Geek. I didn't realize it was just complaining without continuing. Oh, I don't really want to do that. That's going to make for a bad day. All my libraries are gone. That's okay. All right, the other thing I want to do is let's kill this. All right, should probably reboot, but that's not going to happen. Yeah, the thing with uninstalling that is I've got so much stuff that I normally use installed that it's like, really? But I'm more interested in getting this thing working, so we'll just go with that. All right, and then do I want to do, let me see if I have, how many female header pins I have. The problem is I don't have, I guess this just needs 2 rows, and I'd rather have header pins on them so that I can So that's one option. I can do stacking headers. It's not really what those are meant for, but I don't think I have just female. Darn. Okay. Let me think. How do I want to do those then? Or do I just put regular header pins on? The problem with that is all my jumper wires are not as easy to deal with then. I see a Vivado icon on the taskbar. Are there any FPGA related videos on this channel? Not really. I did I looked at the Arduino Vidor like a year ago, but I didn't really do much with it other than the basic stuff. And then outside of that, I haven't done much FPGA stuff yet for the channel. I have done FPGA stuff for my day job, but nothing that would have shown up here. So, all right, let's do this. All right, so that's done. If this works, then all this solder setup will be for naught. But I'd rather get it ready in case we need it. So I'll go to Board Manager, and we'll look for SAMD, Arduino SAMD. Oh, this bothers me. Why does it think it's already installed? Do they get installed by default? I don't think so. All right. Open this up. Thank you, multimeter. Tools, board, native USB. I always forget which one it's supposed to be. Verify. All right. Well, we don't need any of this. Make sure the iron is off. It is. The problem wouldn't be resolved if there's a corrupted library in the module folder. Absolutely true. I did think about that. But it compiled this time, so Okay, plug this back in. So clearly it's not COM10 because COM10 was what? Okay. My God. All right, let's see what happens. This circuit measures some resistance value from some meter and provides digital representation with resolution based on the factor of resistor values, blah, blah, blah. You got it. All right. It's trying to upload. I don't know. I'm on the native USB. Okay. It is the correct port. BOSIC is trying and nothing is responding. Yeah, the shorter description would be, I want to measure an unknown resistance, but I want different resolutions. So we're going to select different R1 values of a voltage divider. Well, this does not look encouraging because it looks like it's locked up. So what happens if we pull? Okay. Tools, native port, that's what I'm connected to. Port, it thinks that is my port. I'm going to try again, but I don't have a lot of hope. Found COM13. All right, so this time it caught the reset. Okay, and if we look, we're flashing about the right rate. So now what I'm going to do is change my delay value. And this is what I do every time I start, because this way I know for certain my tool chain is working. So upload again, and the blink rate slows down. Okay, so, man, I am really tempted. I don't know why this would work now, but we're gonna try. Oh, I guess I just do build. Nope. Okay. That's fine. Whatever. I didn't want to use you anyway. I'm going to move this back over here. What I really would like to do, though, I really do want to use Sublime. So what I'm going to do is just, where's this at? Projects, Arduino IDE. Should be one in here called Live Stream 3906. So we're going to open up this, close that, go into Preferences, and then do, where's it at? Where's Use External Editor? Use External Editor. All right. So 100, save, upload. We'll just do that. Make sure your base libraries are up to date. Yeah, I should totally make sure that's the case. Actually, you know what I'm going to do, because you guys have given a couple suggestions. That's not even English. Update base. Check installed libs. Okay. I'll do that later. Don't need to do that on stream. Okay. 100's working. Cool. Okay. Fix pin mode on Sublime. Yeah, you caught it before I did. Why don't you use VS Code or Platform IO? First, yeah, sir. Good to see you, man. Haven't seen you in forever. The primary reason is simply that I started using Sublime Text years ago and just never switched over. I have used Platform IO though. It's cool. I like it, but I tend to like to use Sublime better because it's more of a text editor. And so I don't really want a full-blown IDE because I don't know. Anyway, I don't have anything against VS Code or Platform IO. It's just I've been using Sublime for so long that I didn't want to switch. Yeah, so I mean, it's useful, saves a lot of time. Yeah, like I said, Platform IO, it's fine. I've used it before. It works, but it's not what I use. Just from a matter of inertia. And what I've found is like switching, I don't know, Sublime Text just fits my workflow better. That said, while I like using it, even today when people ask if they should get into Platform IO or Sublime Text, I do tend to push people towards Platform IO because I don't really have a compelling reason to stay with Sublime Text other than it's what I know and I use it for some other things that I don't think Platform IO can do. So that's why. Okay. Now we can get back to fun stuff. Let's look at our circuit. Got that going. Okay. What we're going to do now is, so what I want to do is we're going to select a resistor branch. This isn't Python. Select a resistor branch, and then we'll select a resistor branch, then measure analog in, and then, oh crap. On the M0, what is the maximum voltage for analog in? It's probably 3. Good point. Good call. But I'm thinking of the ESP, because the ESP's analog input is only 1 volt. The other thing I can look at is Adafruit M0 Feather. I bet. Actually, I'm going to ask you guys a question in just a minute, because I just thought of something. Nope. I thought this might have like the max voltage. I was thinking this will get me close enough. Or no, it won't. I love to work with Eclipse IDE. I'm sorry, we can't be friends. I despise Eclipse. Every time I've ever tried to use it, it's just been a nightmare. I'm trying to think, there was one board, I got a board from TI one time that had an Eclipse-based IDE, and I was super excited because it installed out of the box, no problems, and worked, which was like the first time I ever experienced that. Okay, so 0 is 3.3 volts. Cool. Then we don't have to worry about that. So measure analog in, calculate resistance, and print the value. So up here, let's do this. Oops. So const byte resistor pins. And let's do, I don't have a compelling reason to do anything other than 4, 5, 6, 7. And then const byte sense pin. Let's do a 0. And now we want to do, I want it to do const float R. Now we're going to get out my real values. So R100 is equal to 108.9. R1000, 1K is equal to 0.9 const float R 9.9. Whoa. 10K is 9.94. It's 926. This should be 940. R100 is right. Let's go. If you enable its internal 20K, it will hang at 1.7 instead of the expected 5. I might have missed what you got. I'm trying to catch up with chat. You still use Notepad. Oh my God, at least use Notepad++. Intentionally using non-uniform case. No. God. You guys are... That is the second time he's given me trouble about my casing. All right. Okay. I think that's what I want there. So now let's do serial begin 5200. 9600 is too slow. All right. And then let's do pin mode 13 output. Why not? Oh, yeah, that'd actually be cool if I had LEDs to indicate which one was getting used. Oh, okay. Let's not do that. Although, okay. For int x equals 0, x is less than screw it. All right. So turn on pin 13, why not? And then this will be set up resistor selector pins. And then, all right, should be all we need to do there. The other thing I want to do, serial print live stream 3906 SS. All right. There we go. That way I'll know what program is running when I open up Serial Monitor. All right, so that should be good there. Your size trick probably would have worked. Yeah, I was gonna actually. So what I was originally going to do is, you know, what you could do is say int is size of. So this is a mistake a lot of people make, and I was going to make a point of it. Is they'll say, here's my array, and then I want to do a size of the array. The problem is size of returns bytes. And so in this case, resistor pins is a single byte, so this would work. But if it was an int, this would fail. And so what you really want to do is the size of element 0 divided by the size of int. And so that would actually give us the correct number of elements inside this this array. But instead of explaining all that, I just decided to use a constant variable. But that's why I don't like to do the size of even on bytes, because if you ever change the variable type, then your size of will stop working. Add a end marker to the array and go to the end. Yep, that's actually a lot smarter way to do it, but that's okay. Actually, I really like that idea, because then it doesn't matter. Then you can change the size of the array or the size of the variables, and everybody will be happy. Okay, so now what I need to remember is, I think, to select, yep. So now what we need, I should have done want this. So we're going to do digital write. After I add a dread it, define select it will be low, and not select it will be a high. Digital write. Whoa, what are you doing? X. Wait. Oh, you silly goose. Resistor pins. And I want this to be not selected. Okay. Robert, you absolutely have the, yeah. Okay, yeah, Robert, you got the right way to do the size of. That's right, because you do the, you do the size of the number of total bytes divided by the size of the first element, and that gives you the number of array elements. You're right. Another reason I didn't want to do it, because I was going to get it wrong. Or use pointers. Nope. Pointers are probably the correct way to do it, but I hate pointers, so I don't use them if I can avoid them. Okay, so we deselect them. By the way, I really like using this define trick, because if you're using pull-up resistors or push buttons or anything where logic could be inverted, to me it makes more sense to read the code of I'm not selecting it, and then I don't have to think about should the transistor be high or low. Because I'm using PNP transistors as high side switches, the logic gets inverted from a human perspective, but the code doesn't really care. So okay. Pointers lead to noob madness. Yeah, it does. Or yeah, they do. I would actually like to retake a C and C, or really just a C class, and learn how to use pointers correctly. Okay. So now what we're going to do is let's go byte resistor branch is equal to 0. And then the last thing we're going to do is resistor branch plus plus if resistor branch is greater than or equal to resistor count. Resistor branch is 0. So keep looping around the resistors. And up here, we're going to do, so digital write, what did I call it? Resistor pins, X, select it. X is the wrong thing. It should be resistor branch. All right. So we'll select it, and then before I forget, we will not select it. And then we'll do a print. Oh, print. Oh, whoa. I totally went Python mode. So we're going to do R resistor branch. Whoa, oops. What did I misspell it? There I did. So R resistor branch. Voltage in. So we'll just start there. Let's just get this thing to print the values as one line. Okay. And then deselect and move on. All right. Catching up with chat. Pointers and address to an element. Yeah. But how you use them always gets to me. I'm always thinking about them the wrong way. Cool. I'm definitely going to have to come back and read what you guys are saying later because I might pick up something about pointers. All right, let's see. Is it happy with the syntax? Nope. Missed the semicolon. Compiling. All right, syntax looks good. So we'll come in, we'll enable the, oh, wait, move this. So we're going to come in, we'll enable the I/O pins, which I need to connect, and then we'll go one resistor at a time. Okay, so I need to hook up a couple of things. So first thing we need to do is let's disconnect power. And then we can go R1, 2, 3, and 4. Ground is already connected. Let's okay, I wish I found longer wires. I could turn this around. That's okay. What we are missing though is we need to get, I need to come to, say, right about here. And then I want to go from there to, oh, come on, that's not going to work. I'm connecting up my connection to the device under test. So let's come to about there. And then let's grab a device under test, which in this case is going to be this resistor. That's kind of a mess. All right, all I need is how far away is that going to go? So we'll go there to there, and then we're going to go from here to ground. Was that how I did that? Because this is all ground based, right? Yeah. I'm not doing anything floating, which is one reason why I don't like what I'm doing as a real way to make this measurement, but for the purposes of our exercise, it will work just fine. Okay, so that's connected. There is one more connection I have yet to do, and I'm debating if I want to do, I'm going to actually, what we're going to do is, instead of having the Arduino power this thing, let's get a power supply and set its output to 3 volts and its current to, like, I don't know, will this do 50 milliamps? Something stupid small so that we potentially don't damage anything. And then we can go, let's move these over. We'll put this up here and this one down here. This will be my negative connection. I miss the good old days of COBOL programming. I saw COBOL out of the corner of my eye, so I definitely had to look to see what you're talking about. And then I want to watch current on that. So now we can plug this in. All right, looking good. Voltage still 3.3, so nothing's shorted. Nothing's hot. Okay. Save this. And, oop, wrong one. Go here and say upload. It's almost time for more tea. Serial monitor, 1152. Awesome. I feel like it should be doing something. Yeah, why is it not done programming? No, it has to be. So why is my serial monitor showing nothing? Try something. Okay, that's disappointing. Oh, COM10 is my Bluetooth. That's what that was. Let's go 1152. Disconnect. Then connect. What? What? WTF? All right, I did think of one thing. I should have done delay 100. Let's do that. But I don't understand why. Did it never finish uploading? Done uploading. Open serial monitor. Nothing. What? WTF, mate? What did I do wrong? Okay, good point. We'll go ahead and change that now. I guess on the 0, I'm not going to run out of RAM, so that's not a problem. What? Like, for real? Let's try, so Robert says try replugging the cable. Okay, I'm cool with that. Let's give that a shot. So we do that. It enumerates. Here's the other thing I'm going to do. Or let's just do this. Just want to make sure the code is actually running, because it sure doesn't seem like it. All right, so I don't know if you can see it on camera, but I can. Pin 13 is definitely flashing, so the code is running. Actually, wait a minute. Kaz is onto something. Let's try. Is it supposed to be serial 1, I wonder? So I did the while not serial because I'm waiting for it to turn on. Documentation. That's not what I was looking for. Serial. What's this say? Serial class responds to the programming port. Damn it. Okay. Wait, that's what I'm plugged into. No, I'm not. Okay. So let's try this. And then up here, if I say programming port, and then upload that. I guess I didn't need to re-upload. It should already be working. Hey, Robert. Sorry to hear you're having a rainy day. I'm in California, and this morning it started out raining hard, and it looks like it has stopped raining. So I could go outside, but I'd rather program stuff with you guys. This is way more fun than the outside world. Plus, my monitor has better resolution than the outside world. But I know it's not. Well, why is this being so difficult? Oh, I totally remember this now. Okay, so do I just have to replace serial USB on all of these? change the port or the board. Come on, switch over. And that should be fine. Upload that code. Hey, you don't have to shovel in rain. Yeah, that's a good point. Proper one is COM10. No, COM10 is my Bluetooth device. So I don't know why the debug or programming port isn't showing up as a COM port. Close TerraTerm. It's already closed. All right. So the Arduino Zero uses a different, what do you call it? Serial class. How about that? All right. So I got the delay of 250. We're going to do one more thing. If resistor branch equals 0, delay 750. And then I want to do a serial USB print line. All right, let's upload that. That is done. All right. Now, yeah, I'm going to take a quick break. I made a mistake, and I wonder if you guys can find it. So, yeah, I'll be right back, and then we will continue. Actually, I got a better idea. I'm going to take a break, and then I'll come back and talk about the problem. But even though it's going to say starting soon, I'm going to play the trivia game while I'm gone. So have fun with that, and I'll only be a few minutes. I just need to use the bathroom, get a little bit more tea to drink, and then I'll be back in just a minute. Don't have a shortcut for this. let's try this again. Yeah, sir. Good point on the printf. I was thinking of AVR world and not so much generic C world, but you're right. It's actually part of standard IO. So I will keep that in mind when I update it later. Okay. What I forgot to do is add a wire for analog in. So let's add that now. That should be from here to a 0. Ooh, that's gross. I want to turn that off. Turn this one on. All right. Oh, this is cool. Check this out. So we're getting 4 different voltage levels, which is totally what I was expecting. And so now we need to do a little bit of math to figure it out. And so what is, it's, let's see if I get the, so V out is, what is it? R2 divided by R1 plus R2. Does that sound right? I think that's right, isn't it? And then times Vn, and that should be our voltage divider. Yeah. All right. So there, okay. Before I move forward, let me review where we are at. So we've got, nope, that's not what I wanted. We have this circuit, which is, I was going to call it a mystery circuit, but Robert has guessed it. We're actually building a voltage, excuse me, a voltage divider where we can use IO pins, which is what this section over here is doing, to enable specific resistors or transistors, which then put different resistors into our divider. And so the idea is we should be able to get different resolution based on whichever resistor we switch in to the resistor we're trying to measure. And so the resistor that we're trying to measure. So what we've got built up is this circuit, which is exactly that. These are my PNP transistors. The resistors on the right are my measurement resistors. And then we're connected to an Arduino to the, then we're connected to an Arduino. This is my device under test at the moment, which I think is like a 470K ohm resistor. And so we'll be trying to measure that. Okay. Can you share the Discord link? Yeah, let me just do it this way really quick. AddOhms.com/Discord. Oh, that might not go through. Let me try something else. You're on, yes. Okay, if it doesn't show up in the YouTube chat, it'll at least show up on the screen. You kids still say cool, right? God, I hope so. Okay, so we've got that built up. Now, if I go over to our Arduino code, what we can see the Arduino doing, pull that up, where are you at? Sublime Text. So the Arduino code basically just comes in, we enable one of our resistor branches, we measure the analog in, and then we are just printing the values out. So I haven't done any of the math yet. I'm just, all this point, I just want it to cycle through different resistor values. And so that's all we're doing at the moment. So what I want to do now is, since we can see these resistor values, which are basically let's call it 800, 300, 45, and 4. I'm just going to grab another resistor of different value and see what it measures. Yeah, let's use this one. Okay, so pull this out and take this one and put this one in, put this one in. Oh, come on, get in there. Get in your hole. Maybe, maybe, maybe. Nope, it's not going. This one is all jacked up. Man, maybe I should have used a worn out breadboard. This thing is just like murdering wires. All right, cool. That's what we want to see. Now I want to get my Arduino out and build something, but seriously, I'm a total noob at it. Oh, Robert, everybody starts somewhere. Okay, so we're definitely getting different values, so that's cool. Let's, well, hopefully in a few minutes, we'll actually know what those values are. So V out is like, that's the number of steps. R2 is my unknown, R1 plus R2 times 3.3. So it should be doing, I know you can't really see this, but I'm just working through the math on this because I'm not, divide by 3.3, and that's going to be R2, R1 plus R2. How do you do this? A new definition for resistor, resist the breadboard. Yeah, because that's totally what's happening here. Algebra's just failed me all of a sudden. Hold on, I gotta check something real quick. Does this just give me the, I don't want to do the math myself. No. I don't want a calculator. What I'm trying to remember is what's the, yeah, but what I want is, I want the inverse of this without doing all the hard work. What is, yeah, I want, if it's V out is equal to Vn times R2 divided by R1 plus R2, how do you solve for R2? There's a really simple trick, and I'm totally blanking on how to do this. Right? Seriously? All right, guys, help me out. I can't do simple math at the moment. How do we solve for R2? Yeah, isn't it like, I can't believe I'm having trouble doing algebra and I'm not even drinking. Because isn't it V out times R1 plus V out times R2? And then that's going to be equal to VI times R2. I'm totally doing something stupid because then you get V out over Vn times R1 plus V out over Vn times R2 is equal to Vn. No, sorry. R1 times V out over Vn minus V out. All right. And then Yasser saying R2 is equal to V out times, is that, what? R1, what? Okay. Okay. VI times R2 divided by R1 plus R2. Well, that doesn't help me. Yeah, I like algebra. I don't know why this is giving me a hard time. But see, this one doesn't work because, well, that's just the regular. Equal to, I'm going to write it down exactly as you wrote it. Minus V out. Okay. And so now if I reorganize that, that's V out times R1 divided by Vn minus V out. R2 equals that. Okay. I was feeling really self-conscious because I didn't see how to do it. And I'm super excited you guys are helping, and I'm very happy to see I'm getting multiple different answers. So that's cool. I feel much better. Okay, so let's just try something. Let's get pcalc. So in this case, with the resistor I've got in there now, so we're saying R2 should be equal to V out. All right, let's measure V out real quick. What am I on, volts? Oh, shoot. The problem is it's switching through. Oh, poop. Okay. I was going to do it that way, but what we're going to do instead is we're just going to go straight for bust. Hardwire it with the jumper remove. Yeah. Okay, let me. That's the right way to do it. So what we can do is I'm going to turn this off. Let's close the serial monitor. And then disconnect this. So what we're going to do now is instead of a 0, yeah, the problem is, okay, we're just going to write the code. I don't want to make that many changes. So what we're saying here is Vout times R1 divided by Vn minus Vout. Okay, so in this case, Vout is, I'm going to say voltage measured. And Vn, we're just going to assume it's 3.3 for the moment. All right, and then R1 is whichever of the branches we're in, which I just realized means we should have put these into to R100, R1K, R10K, R100K, right? All right. So then let's just, for the sake of debugging, then we'll say float current R1. No, selected R1 is equal to, oh, what did I just call it? What? Oh, R1 values. Is R1 values for resistor branch. That's just, again, that's just for debug. And then I'm going to keep that for a second. And then we're going to do the actual math. Float, calculate it, calculate R2 is equal to voltage measured times selected R1 divided by const float voltage in is equal to 3.3. Voltage in minus voltage measured. Right? I think that's what you guys told me. Well, Robert, the problem with yours, that's just the equation for Vout. I already know Vout. What I don't know is R2, so I'm solving for R2. All right. Shut up. Sorry, guys. Let me know when you can't see things. I wasn't thinking on that one. All right. Okay, so I think this is what you guys told me. So it's going to be the V out times R1 divided by Vn minus V out. Did I get that right? Yep. All right. So here what I'm going to do is print, I got the wrong screen, this serial USB print. And then serial USB print. No. Where did you get that from? Were you watching the trivia? I think it was watching the trivia. Calculate R2. Serial USB print line. Volts. All right. Okay. See if there's any syntax errors. R1K was not defined. Okay. Because I mixed my case, which Tisboyo is going to definitely give me a hard time about later. All right, let's verify that. Looks good. Upload that. Oh, you know what you know what we should have done? I should just build a static circuit. I think that's what Geekboz was saying. Yeah, negative? Totally. That sounds right. How is that even possible? Oh. Oops. So, duh. We're multiplying by the steps of the A to D converter and not by the what do you call it? By the actual voltage. So there's a lot more optimized ways to do what we're about to do, but I think this is a better this is just going to be a better way to do this. So voltage measured, and that's going to be equal to it's the voltage divided by 1024. I would like to hear arguments or reasons that it should be 1023 or 10. Wait, is it 1024 steps, or is the A to D on this one higher resolution than that? I don't remember. Hold on. Let's take, no, shoot. It just creates the mirror effect. Firefox, come back to, nope, it's none of these. What I was wanting is store Arduino 0. Zero is 12-bit. Yeah, that's what I was thinking, is that it's actually a 12-bit ADC. It's the DAC is 10-bit. That's what I was thinking was 10-bit. I think that should be correct. So we'll read in a value, we'll multiply it by the weight of each bit. So Yasser's saying do power 2 to the oh. Are you saying do, instead of 496, are you saying I should do Okay. Here's what we're going to do. I'm going to leave it like this for the moment. And we are going to, because I've never done an analog input on this processor before. So let's just do a really quick experiment and make sure we understand how it's working. Let's go positive. All right, breaking my own rule and making changes while powered. And then we'll do this. Didn't quite make it. So we will add a wire to go to a jumper wire. So basically I'm going to build a quick divider that we can just measure, you know, without doing all the other stuff. And then I will we'll just write another quick program just so that we can verify that that we know what the resolution is running at, all that stuff, because I don't want to get caught up in that mistake. I'd rather we focus on the questionable algebra skills that I have. And we'll go from there. So this should be a divider at this point. And if I get out the loud multimeter, I guess we don't need that in the frame. So on Sunday, if I do a live stream, we're going to actually, this is a Bluetooth multimeter. We're going to make it so that right above my head will be what this thing is reading. So I think that'll be a fun project. So 3.3 volts here and 1.625 volts here. Well, the algebra part was me trying to figure out R2, but that's okay. Okay, so we got that. Now we're going to move a 0 over to here. And we're going to go back to our Arduino sketch. Disable external. And we'll do serial begin 115200. Oops, made a mistake. Serial USB begin. And then down here, we will do analog. Let's do, oh yeah, I need to change that to ADC steps is equal to analog in, analog read, A0. And then we want float voltage is equal to 3.3 divided by 496. We're just going to go for that for the moment, times ADC steps. And then we'll do serial USB print. Steps is equal to this. Serial USB print line ADC steps. And now we'll do volts and print the voltage. Save that. Okay. I'm following what you guys are saying. And so we'll do analog read resolution 12. Which should probably happen before the read. I bet, in fact, this should even be in setup, and then let's delay 500. We're still on 0, board 12, upload. If you had a second diode as well as resistor, would be R2D2. What are you complaining about? Why is that red? Is the serial monitor still open? No. Uh-oh. Can't open the serial port. That's not a good sign. Let's close that, close that. I know why I can't open the serial port. All right, plug this back in. I'm learning a ton from the stream. Well, I'm glad to hear that, Robert. It's awesome to have everybody here. As I said at the very beginning, if you weren't here, for a long time, I've wanted to do a stream during the day for me and during the week. You know, I almost always either stream on the weekends or at night. And since I took this week off from my day job, I figured today was a perfect opportunity to do a stream. And this is a project that I have to do anyway, so it's a little more fun to do it with other people. It's also a little bit nerve-wracking to do this stuff while people are watching, but that's okay. You guys are nice. All right, let's try to upload that. Monka S. I've made it as a streamer. That's my first Monka S. All right. Cool. So we're getting about 1.65 volts, which is what the multimeter showed, right? Well, this said 1.625. What I didn't verify, hey Red8, thanks for the follow. What I did not verify was what is my VCC coming out as? Yeah, it's 3.3. So we're off a little bit. Is that a step resolution issue, or is that because the thing that I've never fully understood is this supposed to be the total number of steps or steps minus 1? So if we made it steps minus 1, what will happen? Yeah, I mean, it's not a big enough difference. Let's also try, how do we get, when you print, can I just do this to get 4 digits out of the float? So, yeah, so GeekBoz, 0 minus steps, 0 is a valid response, but I think the reason you want to do 1 less is because there's quantization error, and so the least significant bit is never known, and so 1 state isn't valid, but frankly, I don't know the... Wait, WTF? Okay, now I wonder if something changed. Because now I'm getting 1646. Okay, it's actually correct. Did VCC change? It must have changed when I plugged in the Arduino. There must be, I must have a mistake or something's going on in the circuit because there's voltage, there's unexpected voltage coming from, yeah, something changed. I'm not sure. Your chat is syncing with both Twitch and YouTube. Yeah, and Facebook, but I don't think there's that many people on Facebook. Okay, long story short, this is measuring, or let's see, this is measuring about 1.65. The multimeter measured about 1.65. That is where we want to be. Close enough. Let's move on. So now we will do, yeah, I'll keep it over here. Okay, so that's my reference code. What I did realize is we made a mistake and made a float where we didn't want it. So we'll fix that. So first up here in setup, we have to do, for the 12-bit ADC, we'll do analog, was it analog read resolution, and that's going to be 12. And then down here, this should be an integer for the number of steps. And then we'll measure this by ADC steps. We're getting pretty close to that. No, we decided we're going to say 4095 on this one. So that should be correct. I also need to move this back to my measure point. All right. Let's see what happens. Slayer says, haven't done too much besides getting the LED to light up on a breadboard. That can take quite a bit by itself. No reason to downplay that. That's awesome. Congrats. I think the LEDs are, everyone should start with LEDs. They're awesome. Okay. What did I do? Okay, those numbers make no sense to me. So what did we do? We measured, oh, I know why. We measured the voltage. Oh, wait a minute. No, that is right. Okay. This is actually really close. Okay, this is actually working a lot better than I thought it would. Here's what I'm going to do, just for the sake of, I do want to delay that. If the resistor branch is equal to 0, we'll do, okay, this is actually working the way I expect it, so it just took me a minute to realize what we see. So what I'm going to do is I'm just going to have the serial output go once and then stop so that we can take a better look at what's going on. So on that type of measurement I had issues, take one, throw it away, and then, yeah, you should actually always throw away the first analog read you do. The other thing we should be doing is we should actually average multiple readings just so that we can get a little bit to average out noise, which I probably should do at some point. So cool, guys. Thanks for the follows. Okay, so hit reset. All right, I don't know why it's not resetting. Unless reset doesn't. Anyway, so here we get R0, 1, 2, 3. So remember on our circuit, we have 4 different resistor values, And the I/O pins, that's what's going on with the switch over here, is enabling different transistors, which is putting a different resistor value into our voltage divider. And so what we're seeing is we see 4 different voltage measurements. And then our calculation is based on the current voltage across our unknown resistor and the resistance value, which we measured before we started and we stored as constants. And so here we're seeing our 4 different voltage values, and now we're able to see different resistance values. And so I think what this one is telling me is that a 100 ohm resistor in series with this one is just simply too small of a resistor, so we're not getting a good resistance measurement. I put volts here, but that was dumb. We're actually measuring ohms, not volts. So this is the voltage we're measuring. This is the ohms we're calculating. And what this is showing is we're getting somewhere in the neighborhood of 3.4, 3.2 kilo ohms. And if I look at the resistor, it looks like it's supposed to be maybe a 3, I think that's blue. What is blue? 5? Let's pull this out real quick. Get the loudest multimeter on earth. Where'd you go? I heard it fall. Like, I placed it right here. Oh. Come on. Oh. Yeah, I'm in resistance. Yeah, so it's supposed to be 3.6 kilo ohms. Okay. It's not great. So this measurement, which was R2, which is the 10K, gave us the closest to the correct answer, but it's still off quite a bit. I hate when things are just a bit off instead of all wrong. Yeah, because if it was completely wrong, then I could work that out. Let's do this. I've got another resistor. Let's just see what it measures so that we have a comparison. This up here. Man, these things are just... I cannot get it to go in. Yeah, haha. My other thought is I just talked about doing the averaging. I wonder if I should have averaged the values a few times just to see if we're getting noise. So maybe we will do that. For the sake of science, we're going to try this and then we'll do an averaging experiment. Okay. The thing that was bugging me though is when I hit reset, this isn't resetting. Okay. So now we get, okay, that's really driving me crazy. We got to fix this. And I don't want people that are just coming in to get confused. Volt ohms. All right, upload that. Now, when I came up with this, I didn't really think through the resistor values I picked, and so maybe part of the problem is these are the wrong values to be using. So this one is pretty close. However, it should be, oh, I should have measured it. I should have measured it before I did this. Let me take this out of circuit. And measure what this one is. Hello. So it's supposed to be 198, which this time our 0 is getting us to the closest. Okay, let's go ahead and go this way. Let's do oh, I don't know that you guys saw this. So here's what the values are looking like. With this is supposed to be 100 and what did the meter say? 100 and 180. But these are what the values came out as. So let's clean up our analog reads. So let's do this. We're going to come into here, and then let's do a int throwaway to analog read A0, and if throwaway is greater than or equal to 0, I'm worried that's going to get optimized out. That's okay. No, it shouldn't. In fact, it should be. I should be able to just do that. And then let's do for average count equals 0. Average count is less than 10. Average count plus plus. We're going to delay, let's do 50 milliseconds. And then long total count is equal to 0. Total count is equal to total, whoa, that's not what I want. Total count plus analog read A0. So we'll get 10 readings, 190.8, thank you. No caps, should there be? Well, of course there should be. Actually, let me think about that. Well, yeah, there should have been like a decoupling cap somewhere, but we're moving things slow enough that I think we'll be okay. It would be nice to have a filter cap on there, but then I think it's going to affect what resistors we can measure. So we get a long delay. I do this delay first so that we throw this away, wait a little bit, read, wait a little bit, read. And then we should be able to say int ADC steps is equal to total count divided by 10. Okay, right? I think that's going to work. I was going to wait and have you guys tell me if you see a problem, but average count is not. Oh. Need to do that. Uploading, done, open. Okay. This is so far off. I wonder, wait a minute. I just thought of something. So my divider circuit is 3.3 volts. This is 100 ohms. And right now this is supposed to be, what would we say, 190 to ground, and we measure V out. So that's 290 ohms. So 3.3, 290. Oh, okay. 11 milliamps. Interesting. Okay. I was thinking my current limiting. Yeah, I was thinking current limiting was kicking in, but it's not. What if it doesn't divide to 10? What in the world? Oh. Fair question. What if it doesn't divide to 10? I guess it doesn't have to. The numbers look about the same. Okay. Well, so this didn't work out at all how I expected, because, oh, you can't see that. So this didn't work out at all how I expected. So I was thinking, whenever the voltage divider, whenever R2 had higher voltage across it, that was going to give us more resolution. And so I expected this to be closer to the correct value that we're measuring. But these, well, this is the closest and it's the smallest, so I believe it the least. But it also means there's less current flowing. Okay, now that we've done, I tell you what, now that we've done this averaging, let's come back to our other resistor. I want to clean these leads up real quick. I just thought of something. Okay, hold on. Okay, I'm going to continue with this, and then I just thought of something that that might actually explain why we're getting something wrong. I forgot, and I should have listened to, I think it was GeekBoz, who said something about bypassing the GPIO pins, which would have been a really good idea, because I forgot to account for something in the math that we're doing. And I'm not sure of a good way to do it without measurement. But I want to see what our other resistor measures as. Gunnar comes in and asks, what is he making? We are making a voltage divider / resistance measuring circuit. And the idea is, using the Arduino, we select different resistors to put in series with our device under test or resistor under test to see if we can determine its resistance. And by using different resistors in series, my hope was to get better resolution, but it's actually seeming like that might be overkill. All right, so we'll close this, reopen this. Does it run again? hit reset. That doesn't seem to do anything. I don't get that. So we'll do this, open this, open that. All right. Okay. This is still not at all what I expected. I thought for sure this was going to be the exact opposite. So R0 is our 100 ohm resistor, and it's measuring 2.4K. The others are measuring 3.5. Like R2 and R3 are closer to the value I would expect, but they're also the smallest voltage values. That is crazy. Crazy, crazy, crazy. Let's double check something. So this one is the, looks like brown, black, brown. So this should be 100 ohm. It's green, and it goes to pin 4. And in my code, pin 4 is first. 100 ohm. Okay. 100 ohm. All right. So that should be right. Okay. Okay, here's what I thought of. Let's go do the circuit. So this is just a recap. This is simulating the I/O pin. So I can say, you know, high-low, which enables a transistor. And then this transistor enables a resistor to go in series with my device under test, or my resistor under test. The thing I didn't take into account is I said VCC. Oh, that's not what I wanted. I said in the code VCC. Whoa, come on, stop that. That's why I don't like using the touchpad. Come back. I'm out of USB ports. I don't need that one at the moment. I do need this one. Oh. I got an idea. I know what we can do. Okay, so here's what I got going on. In my actual circuit, I have 3.3 volts, right? And in my Arduino code, I said VCC or VN. I said VN is 3.3 volts, but it's not, because I forgot about the voltage drop of the transistor itself. And so the voltage we're measuring here is not 3.3 volts. It's probably like 3 or a little bit below that. The trouble I have is with the current code, we're switching through each of the transistors. So it was difficult for me to say, okay, well, how do we measure the voltage at each of these? Just realized we've got the right tool to do the job. In fact, I'm going to fire this up right now. Instead of manually changing these, I'm just going to hook up my scope. So let's get this connected. Yeah, I'm all for Bluetooth mice as well, except, which I just didn't think to grab it. It's in my bag. But my desktop mouse, I use a gaming mouse because it's got a bunch of buttons. I don't actually use it for gaming. Instead, I use it when I do video editing. Oh, this is going to work out. This will work. So we're going to attach this to here. No, where I want to measure is, we're just going to pick one, and we're going to measure at the top of this resistor, because I just want to see what one of these looks like at the moment. All right, and then let's go B-roll picoscope. Hey Kaz, glad you're back. You use a trackball? I never got into trackballs. Let's get this loaded up. So basically, I'm just going to use the scope to look at, oh, while that's loading, we can actually modify our code to stop doing this. Upload that. No suitable device found. Well, I can fix that. That's mouse. How did this, oh, here it is. Plug that in. It should find it. All right. So channel over range, let's just tell it to go plus or minus 5. And then we'll set a trigger for, we're going to end up on repeat. And I want it to trigger when it's maybe up here. That should be enough. Maybe down here. Okay, let's change our range to like 1 volt. That sounds good. Increase the memory, and then let's watch for 110 milliseconds. That should be 1 second. Actually, that's probably about as long as I care, because all we're looking for here is what is the voltage range actually doing. So let's do voltage peak to peak. Well, that is not what I expected it to be. Yeah, think about that for a second. Just make time travel possible with the flux capacitor, right? Yeah, actually on the, I'm not gonna, I'll come back to that. Yeah, the reason I use the mouse though is because when I'm editing, I've basically mapped everything my right hand should be doing to a button or button combination on the mouse. And so while editing, I can keep both hands in the same place for most of the time. So like I get all my hotkeys on the left and then my mouse on the right. So, okay. This is not what I expected to measure, which I feel like is like the billionth time I've said that today. But it's not. It's just totally not what I expected. Oh, wait a minute. That's what I wanted. Because I think this, let's see, let's slow back down to 100. Okay, I know what I should have done. Let's add another channel. We will look at both the gate pin. Where's my other scope probe? Like, I want my good one, not one of these. All right, we'll use this one. Oh, I know the other problem. Okay, this is actually, I forgot the picoscope. Okay, actually, this is actually closer to what I expect. I was like, okay, I have a peak-to-peak measurement, and I was thinking, why is it measuring 300 millivolts? And Axel, hey Axel, is absolutely right. Oh, damn it. it's because the scope defaults to a by 1 and I'm using a by 10. And then for some reason, it does not seem to pick that up every time. Where's my trigger point? Let's go like 0.1. Right? Yeah, okay. Plus or minus 2, bring this down. Plus or minus 5. Let's just make it a little bit happier. And then we can do a trigger, repeat, and I'm going to bring it up to here. Okay, okay. We're getting closer to what I was expecting to see, but we're just going to make life even easier and add a second probe. So that I know exactly when the pin is getting activated. So we'll attach this. I've got that one here. And then this one, we're going to ever so gently attach it to here. Okay. Now if I turn channel 2 on, plus or minus 5 volts should be good. Go trigger on anything. And now what we want to trigger on is when channel B rises 1.8, that's good. That's what we're looking for. Oh, that's much better. All right, and then let's just do a single. There we go. All right, so the idea is this red trace is my I/O pin. So this is when it goes down. So that's when the transistor is actually turned on, and this is when it turns off. And so, not quite what I expected. So, okay, there's a behavior that's happening that I didn't expect. Okay. Okay, just to back up for those asking, so here is the circuit that we're building onto a breadboard. Basically, we've got 4 transistors controlling 4 resistors in series with an unknown resistance or my device under test. And then the Arduino is cycling through these resistors, measuring them enabling them one at a time while we do an analog read. What I realized is my measurement did not take into account the voltage drop across the resistor, so we're not getting very good readings. But to give you an idea, this is what we're actually measuring. So here's the 4 resistor values, and here's the voltage for each of those 4 resistor values. And so it's supposed to be a 3.6 kilo ohm resistor based on my multimeter. And so in this case, R2 is getting really close, but it's not quite there. And what I got to thinking is I need to figure out what is the voltage drop across the resistor. So I hooked up my scope. The red channel is measuring the GPIO pin, so I can tell when I enable the transistor. And the blue trace is just measuring on the collector of the transistor. And so I can actually see when the other pins are getting activated, which bothers me a little bit. And then I see this one, and it's right at like 3.3, 3.4 volts. So I'm not seeing the voltage drop that I was expecting. So it's a resistance measurer. Yeah, basically a circuit to measure resistance with various resolutions. Okay. Let's move the probe. Wait, yeah, that's okay. I need to move this one anyway. To here. I just want to see what another resistor looks like. Okay, so let's do a single shot of that. Yeah, same thing. I want a cursor, and this is coming down to 3.283, so we're losing 100 millivolts. I don't know. This is really shady. I'm just going to change the voltage. See what it does. Interesting. That's amazing that all I did was change. Wait a minute. Oh my gosh. Wait, did I upload this? Upload. Interesting. That is really interesting. Oh, I know why. Because the V out, or V in minus V out, is the... So if we just drop this down to 325, which is what the scope is saying, but I don't entirely trust the scope because it's kind of a noisy measurement, but we're going to try anyway. Huh. Wow, I did not expect 10 millivolts to matter that much. Okay. Now let's take this resistor out. What's it do then? It goes nuts because it doesn't know what's going on. And put our other one back in. Okay. Come from here to here. Okay, so still not the results I expected, but it's working better than I anticipated it would. So this was supposed to be, Salmon, where'd you go? We measured this one as, I think 100, I think we measured it at 190 before. So effectively, the circuit's doing what I want. It is using different divider values to give me different resolution on the resistance. The problem is, I'm not sure I see how I would like encode which would I pick, because R0 and R2 are effectively measuring the same thing. Although R2 is, I'm not getting as much resolution or range as I thought I would. I thought these were going to be much wider, where I could look at this and say, oh, clearly this is wrong, and this is wrong. But I can't really say that. So I got to think about what I'm doing, because the circuit's working as it's in... The circuit appears to be working correctly, but it is not how I intended it to work. And that bugs me. Okay. I think I'm going to wrap up. I need to get some lunch, and I want to think about this a little bit more and think about what I'm going to do next. Yeah. So we'll do that. I want to thank everybody who submitted or who's been helping out in the chat. One thing I'm going to do is at the beginning of the live stream, I ran a trivia quiz. So I'm going to run that as I'm wrapping things up. And yeah, let me tell you about a couple of things before I stop. So let's go to the web. I just wanted to mention that that's not my laptop. So I am a host on Element 14 Presents, and I just had a video come out today on function generator basics. So I recommend you go and check that out. It's part of the show Workbench Wednesdays, which every third Wednesday we have an episode. As you may or may not guess, the circuit we're working on now is related to a video I'm working on. So I'll let you think about what it's going to be. I also wanted to tell you that Element 14 is doing some holiday giveaways. And so they're actually giving away things like a USB-based scope, as well as some pliers and a multimeter and a bunch of other cool stuff. And if for no other reason, you want to go check these out, because I can't find the video now. Well, long story short, I wear elf ears and a funny hat. So go check out those giveaways. All right, guys. Thank you so much for joining. And and then the last thing is, if you want to keep the conversation going, we do have a AddOhms Discord. Just head over to the redirect link will be addohms.com/discord, and that will drop you into our server. So feel free to come by and say hi. For now, let's see who can answer some trivia. Thanks again.